This is Honors Geometry Lesson 7-7, Extension Law of Cosines. So we talked about the law of sines, and we said use that when you are given an angle and a side across from it and one other piece of information. Now there's another formula called law of cosines, and you're going to use this formula when you have three side lengths or you have two side lengths and the included angle. Now the angle is not across from one of those sides. And again, it doesn't have to be a right triangle. Any kind of triangle works. And here's the formula, and you could probably guess it's derived from the Pythagorean theorem. So let's go ahead and give this a try. All right, so we have what we need. We have two sides with the included angle, and they're asking us to find the side length AB. So I'm going to go ahead and just put an X there. Okay, we'll call this side X. So here we go. The formula is c squared equals a squared plus b squared minus 2ab cosine of c. Okay, just like law of sines, don't get hung up with the a, b, and c because they're not always going to necessarily call the triangle ABC for you. What you need to know is that you either start with the unknown or you finish with the unknown. Okay, and as in law of sines, your angles are A, B, and C, and the side across from angle A is side A, the side across from angle B is side B, and the side across from angle C is obviously side C. So in this case, we're looking for this side. So that's my unknown. And what we have is this cosine of C and the two other sides. So that's where we're going to go with this. So again, my unknown is c squared, or in this case, we'll call it x squared. And then the other two sides, doesn't matter which is which, just like in the Pythagorean theorem, I'll say 13 squared plus 29 squared minus 2 times, and you repeat these two numbers, the a and the b. So in this case, it's 13 times 29. And then cosine, that's the angle across from the missing side. In this case, it's cosine of 41. So again, if you always remember your unknown is either this or this, you can't go wrong, okay? So you either start with the unknown or you finish with the unknown. So let's go ahead and simplify that. The nice thing about this, you can see this, our unknown is already isolated. It's over here. So I'm going to go ahead and punch this in my calculator just the way we see it. I'm going to punch it in as 13 squared plus 29 squared minus 2 times 13 times 29 times cosine of 41. And that tells me that x squared, or c squared if you like, equals 440.9, we'll say. And then now, of course, we have to square root both sides. So I'll say second square root 440.9, and it tells me my missing side is about 21 units, okay, which seems like a reasonable answer if that side's 29 and this side is 13. Let's try it again. So our unknown in this case is side BC. So again, I either start with an unknown angle or the unknown side, so they're across from each other. So let me make some room to work here. So I'm going to start with x squared, my unknown, or c squared if you'd like. And then it's the other two sides, just like in the Pythagorean theorem, 21 squared plus 30 squared minus 2 times, and you repeat these two numbers, 21, 30, and then cosine of c. Again, we don't care what c is. C has to be the angle across from the unknown side. So in this case, we're going to say cosine of 123. All right, again, we're just going to punch that in our calculator just the way we see it. 21 squared plus 30 squared minus 2 times 21 times 30 times cosine of 123. And it tells me it is 1,000 590.2. And then we're going to go ahead and square root both sides. And we see our missing side is about 40 units long. Okay. All right, you know what's coming next. We're going to go ahead and do the same thing, but now the unknown is an angle. Okay, oops, that's your try. Okay. All right, so we're looking for angle A. So again, you either start with the unknown or finish with the unknown. So in this case, we're looking for an angle. So that means we start with the 14 squared. Again, the formula c squared equals a squared plus b squared minus 2ab cosine of c. So in this case, our unknown is this angle. So that means we're going to start with the side across from it. So in this case, we're going to start with 14 squared equals, and the other two sides are my a and my b, 6 squared plus 9 squared minus 2 times, we're going to repeat these numbers, 6 times 9 times cosine. In this case, we don't have it, so if you want to call it a, if you want to call it c, whatever. Okay, here's where it gets a little tricky. This time our unknown is mixed up in this big jumbled mess. So first thing I want is 14 squared, so that's 196, equals 36 plus 81 minus, I'm going to go ahead and multiply those three things together. 2 times 6 times 9 gives us 108 cosine of A. Okay, be careful. Don't be tempted to combine these three together, because remember that 108 is attached to the cosine of A, which is its coefficient. We can't combine it together. It's like it has an x there. So I'm going to go ahead and just combine these two together, not including the 108. So I bring down my 196. So I take 36 plus 81. I get 117 minus 108 cosine of A. Again, I can't combine those together because this is attached. So I'm going to go ahead and get rid of my 117. Subtracting it from both sides, and I get 79 equals negative 108 cosine of A. I'm going to divide each side by negative 108. So I get cosine of A equals, I'm going to take 79 divided by negative 108, and I get negative 0.7315, we'll say. Usually you go at 4 decimal places. You don't want to round any less than that. So you know we're looking for an angle, so we have to do the backwards. So we expected to get a decimal. We haven't seen many negatives before. If you get a negative, it means the angle is going to be obtuse. Okay, so let's go ahead and try that. So we need to do the inverse because we're looking for an angle. So I'm going to press second, cosine negative 0.7315, and it tells me my missing angle is about 137 degrees. Okay, all right, for the sake of time, I'm going to skip that next one. And I think that's it. Okay, please give the exercises a try. Let me know if you have any questions. Thank you. I think I will. If you're interested, let me go ahead and do one more with you. If you don't need it, that's perfectly fine. Go ahead and move on to the homework. But if you think you need a little bit more help, let me go ahead and do one more example with you. All right, so let me go ahead and write this formula down for you again. It's c squared equals a squared plus b squared minus 2ab cosine of c. So in this case, they call it theta. That's the Greek letter. We're looking for that angle. So remember, we either start with this or this. You always start with the unknown or end with the unknown. These are our a's and b's in this case. So in this case, I'm missing the angle, so I'm going to start with the side across from it. So that's going to be 35 squared equals the other two sides, 39 squared plus 47 squared minus 2 times, repeat these numbers, 39, 47, and then now what we don't know is cosine. You can call it A, B, theta, whatever you want to call it. I'll just call it theta. Now I'm going to simplify a little bit. 35 squared gives you 1225 equals, okay, I know I'm allowed to combine these together, so I'm going to go ahead and combine those together. 39 squared plus 47 squared equals 3730. I'm allowed to combine these together. So I have 2 times 39 times 47 gives me minus 3666 times cosine of theta. All right, we're going to subtract this 3730 from each side. 1225 minus 3730 gives me negative 2505 equals negative 3666 cosine of theta. Divide each side by negative 3666. And so I get cosine of theta equals, here we go, 2505 divided by 3666. And it's positive. Negative divided by negative is positive. So I get 0.6833. Again, you want to go out usually 4 decimal places. So now we're looking for an angle. So now I know I use the inverse or backwards cosine. So for a second cosine, 833. And it tells me my missing angle is about 47 degrees. Now, please try the practice exercises. Let me know if you have any questions. Thank you.